Welcome to This Explainer. Today, we're going to completely transform the scientific method. We're taking it from a dusty, standard textbook concept and turning it into a practical, hands-on, and honestly, incredibly exciting inquiry journey. If you've ever looked at the world around you and just wondered why or how, well, you're already thinking like a scientist. So let's dive into how we can structure that natural curiosity into a serious tool for discovery. Okay, so let's get right into it. Rather than just talking about abstract steps in a vacuum, we're going to use a specific real-world mystery to guide us through our entire investigation today. The big question is, how does the amount of sunlight affect mung bean plant growth? This single question is going to be our anchor. It's going to show us exactly how a random idea transforms into concrete, verified evidence. Here is our roadmap for This Explainer. Section 1. The spark of curiosity. Section 2, preparing the investigation. Section 3, gathering the evidence. Section 4, interpreting the data. And finally, Section 5, concluding with confidence. Section 1, the spark of curiosity, asking the right question. Step 1 is defining our aim or problem. The absolute key here is to make sure your question is clear, specific, and most importantly, testable. We aren't asking a philosophical question like, are mung beans happy in the sun? No, we're asking, how does the amount of sunlight affect their growth? That gives us a very specific target and sets the stage for the whole shebang. Section 2, preparing the investigation, gathering materials, and setting procedures. Step 2 requires us to list and gather our materials and equipment. Notice exactly what we need to pull this off. Mung bean seeds, 3 plastic cups, soil, water, a ruler for measuring, labels to keep things organized, and a notebook and pen to record the journey. Trust me, having all this prepared ensures you aren't scrambling around in the middle of your experiment. Next up is Step 3, which involves creating our method or procedures. This literally means writing down our actions in a strict, ordered list, so our test is highly reliable. Anyone should be able to pick up your procedure and replicate your experiment perfectly. We're putting soil in 3 cups, planting the same seeds, placing those cups in different sunlight conditions, and then watering them equally while measuring daily. Notice the heavy emphasis on keeping certain things the same and equal. Now, that brings us to an absolutely crucial concept: control variables. These are those important conditions in an experiment that are kept exactly the same to ensure a fair test. Think about it. If we gave one plant more water, another plant better soil, and another plant more sunlight, and one grew taller, how would we know which factor actually caused the growth? We literally wouldn't. That's exactly why we must give every single cup the exact same amount of soil and water. The only thing we allow to change is the sunlight. So by following our procedural steps carefully, we ensure our 3 mung bean cups are perfectly set up in their respective environments. We've got one getting lots of sunlight, one getting some sunlight, and one stuck in little to no sunlight. The stage is officially set for science to happen. Section 3, gathering the evidence, observation, and data collection. Step 4 is all about the results and data. This is where the real daily fieldwork begins. The job now is to be incredibly observant. You got to look closely at the leaves and stems, measure exactly with your ruler so there's zero guesswork, and faithfully write down what you see. You are basically acting as a real-time reporter on what nature's doing. Check out this actual sample data recorded over a 7-day period. We're tracking the height of our plants in centimeters. Notice the numbers here. On day 1, they are all sitting pretty at 0.5 centimeters. But by day 3, a clear gap starts to open. The plant with no sunlight is at 1 centimeter, some sunlight is at 1.8, and much sunlight is at 2.6. And wow, by day 7, the differences are massive. 2 centimeters versus 4.6 versus a towering 7.8 centimeters. The numbers are definitely starting to tell a compelling story. Section 4, interpreting the data, finding the patterns. In Step 5, we analyze and interpret our results. Data alone is just a bunch of numbers, until we play detective, right? We do this by comparing the heights visually, looking for clear patterns. The whole goal here is to let the data tell its own story, without our personal bias getting in the way. So when we map out our mung bean numbers, what pattern actually emerges? Well, our analysis makes the pattern completely undeniable. The plant receiving much sunlight grew taller each day, while the plant with no sunlight grew the least. We've established a direct, mathematically backed relationship between the amount of sunlight and the height of the mung bean plant. We didn't just guess this, we proved it. Section 5. Concluding with confidence. Answering the question. Step 6 is drawing a conclusion, and this brilliantly illustrates the full circle of the scientific method. You answer your original question, but you do it using the hard evidence from your results. So for our experiment, we confidently state, because the mung beans with more sunlight grew the tallest, sunlight absolutely affects growth. It's a simple sentence, for sure, but it carries the heavy weight of verified scientific proof right behind it. By following these 6 structured steps, from your very first question to your final conclusion, you're doing much more than just a project. You're actively practicing the foundational habits of good scientists everywhere. You're learning to ask probing questions, plan your actions carefully, record your data honestly, analyze fairly, and always, always conclude with hard evidence. Ultimately, as we wrap up, I want you to remember this deeply empowering takeaway from our investigation today. Science is not about being right, it's about finding out. Honestly, if our plant in the dark had somehow grown the tallest, our initial hypothesis might have been completely wrong, but our science would have been a total success because we uncovered a truth. The goal isn't to guess correctly. The goal is to seek the truth through evidence. Now that you understand how to use this incredible, structured tool for discovery, I want to leave you with one final thought. The world is just full of variables waiting to be tested. So what hidden truth about the world around you are you going to uncover next using the scientific method? Thank you so much for joining me on this explainer. Stay curious, and I'll catch you next time.